Welcome to the video lecture on polynomials, adding, subtracting, and multiplying. Let's start by defining what a polynomial is. A polynomial is a term or finite sum of terms of the form ax to the n. A is called the coefficient, and it's any real number, and n is any whole number. So some common examples of polynomials would be just a constant all by itself, for example, the constant 3. Or you could have just a variable by itself, like x. That's a very simple polynomial. Or you could have a single term that has both a coefficient and some power of x, like 2x cubed. Or you could have a sum of a couple of terms, like 3x plus 2. You could have something a little bit more complicated, like x squared plus 5x plus 6. Or you could have something even more complicated with a whole bunch of terms added or subtracted together, like 3x to the 5 minus 4x cubed plus 2x minus 7. And notice in this last example that the x squared term is missing. So you don't have to have every single term accounted for. And the highest term, the term with the highest degree, is the degree of your polynomial. So in this last example, this would be called a fifth degree polynomial. Now, a monomial is a polynomial with just a single term. So this could just be a single constant, like 3. It could be a single term like 2x, or it could be a single term like negative 5x to the 7th. Okay, those all have only one single term. A binomial is a polynomial with exactly two terms. So something like 2x plus 1 that has two terms, or maybe x squared minus x that has two terms as well. A trinomial is a polynomial with exactly three terms. So this would be something like x squared plus 5x minus 6, for example. Okay? So we're going to start working with our polynomials, and we're just going to do some basic arithmetic. So we're going to start by adding and subtracting polynomials. Now, this is something you already know how to do because you've already learned how to combine like terms, and that's exactly what it takes to add and subtract polynomials. You're just going to combine your like terms by adding or subtracting the coefficients of the like terms. So, for example, if I have x squared plus x minus the quantity 3x squared plus 2x minus 1, the very first thing that I want to do here is make sure that I distribute this subtraction across to every term in this second set of parentheses. So I'm going to take a step here to distribute my negative. And in this first polynomial right here, there's no coefficient in front, there's no negative, there's no constant out front. So these parentheses really aren't even necessary. So I could just rewrite this as x squared plus x. I don't even need those parentheses at all. But in this second set, I want to make sure that I distribute my negative across. So this would become negative 3x squared, negative 2x, and then negative times negative 1 becomes positive 1. And now all I want to do is combine like terms. So remember, like terms should have the same variables raised to exactly the same powers. So for example, this x squared and this minus 3x squared, those are like terms. Now there's an implied coefficient of 1 in front of that x squared term. So when we combine these like terms, we're just combining the coefficients. So we're going to do 1 minus 3, which is negative 2, and the variable portion of it stays the same. So that would be negative 2x squared. And then I have a plus x and a minus 2x. So that's like a plus 1 minus a 2, which is a negative 1x. And usually we don't write the 1 in front. It's more concise, more simplified if you just write it as a negative x. And then this plus 1 on the end doesn't have any like terms to combine with, but it's still there. So I just want to make sure that I carry it over to my answer. So here would be my solution. Okay, so let's try that again on this next example. Again, this is subtraction, so I have to make sure that I remember to distribute this negative across to the second set of parentheses. The first set of parentheses aren't necessary because there's nothing in front that needs to be distributed. So this would just be 9b cubed minus 4b squared plus 3b minus 2. And then when I distribute, a negative times a negative becomes a positive 2b cubed. Negative times negative becomes a positive 3b squared. And a negative times a positive stays negative, and that would just be a negative b. And now I look for my like terms. So I'm going to start with my b cubed term, which would be here and here. So that's a 9 plus a 2, which would be 11b cubed. Then I have a minus 4b squared and a plus 3b squared. So negative 4 plus 3 would be a negative 1b squared, or just a negative b squared. And then I have a 3b and a minus b. So plus 3 minus 1 becomes a positive 2b. And then I have, again, just this solitary constant, so that's going to carry down and just be a negative 2. So here's my final answer. And notice in this example, I start with my b cubed term, then I went to my b squared, then my b, and then my constant. That's called decreasing order or descending order. And you don't have to write your polynomial in descending order, but that's how we often do it in mathematics, so that it's easy to see what your highest degree term is at front and to see what terms are accounted for. Okay, so we just talked about how to add and subtract polynomials. The next thing that we're going to talk about is how to multiply them. And there's different scenarios that we have to take into consideration. So we're going to start simple with just a monomial times a monomial. So that's a single term times a single term. And to do that, you're just going to multiply the coefficients together, and then you're going to multiply the variables together. And when we multiply the variables together, we have to use our laws of exponents. So when you multiply an m to the 6th times an m to the 4th, since the bases are the same and we're multiplying them, we get to add the exponents. So if we multiply the coefficients first, negative 3 times 5 would be negative 15. And then if I multiply the m's together and add the coefficients, this is going to stay an m, but 6 plus 4 means now I'll have an m to the 10th. So this would be what I get when I multiply these two monomials together. Now let's make it a little more difficult. So this time we're going to take a monomial, a single term, times a polynomial, or many terms. And in order to do that, we're just going to distribute this monomial across to all three terms. And every time we multiply it by a term, we're going to do coefficient times coefficient, x's times x's, and y's times y's. And when we multiply the x's times the x's, remember again that we are multiplying the bases, so we add the powers. And the same is true for the y's. So when we multiply the y's together, we're going to be adding their powers. So let's start by doing 9 times negative 3. That would be a negative 27. And x times an x squared. Now remember, this is like an implied power of 1. So x to the first times x squared, when I add those powers, that's going to be 1 plus 2, or 3. So I'll have an x cubed, and then a y cubed times a y to the 4th. 3 plus 4 gives me y to the 7th. Now I go to the middle term. So 9 times a positive 6 is a positive 54. An x times an x, that's like an x to the first times an x to the first. 1 plus 1 is 2, so this will be an x squared. And a y cubed times a y to the first becomes a y to the 4th when I add those powers. And then finally 9 times a negative 2 would be a negative 18. An x times an x is an x squared. And then that y cubed just stays the same because I don't have any other y's to multiply it with. And here would be our final answer. None of these terms are like terms because they all have different combinations of powers. So we're not able to simplify this any further. Okay, now we're going to make it a little bit more complicated by doing a polynomial times a polynomial. So many terms times many terms. Again, this is really just our distributive property at work. So we want to make sure that we take every term in this set of parentheses times every term in this set of parentheses. So if you think about it, we have 2 terms in the first set of parentheses, and we're multiplying those by 3 terms in the second set of parentheses. So initially, we're going to get 6 terms right from the start when we do our distributive property. So I'm going to start with my 9y, and I'm going to multiply that times all three of these terms in the second set of parentheses. And remember, again, it's coefficient times coefficient, and then you add the powers on the y's. So 9y times 8y squared would be 72, and y times y squared becomes y cubed. 9y times a minus 6y is a minus 54, and y times y is y squared. 9y times a positive 1 is a positive 9y. So that's this first term times all three of these. Now I need to take the negative 2 times all three of our terms. So negative 2 times 8y squared is a negative 16y squared. Negative 2 times a negative 6y is a positive 12y. And negative 2 times positive 1 is negative 2. Now before I stop here, I want to make sure and see if I have any like terms. And in this case, I do. I don't have any other y cubes, so this 72y cubed will stay the same. But I have a negative 54y squared and a negative 16y squared. And negative 54 and negative 16, those are both negative, so we're really adding those together. 54 plus 16 would be 70, but my answer is going to stay negative. So this will be a negative 70y squared. And then I have a 9y and a 12y, and that adds to a 21y. And then my minus 2 stays off to the side. So here is my answer in descending order. Now the last kind of multiplying that we're going to do here is a very particular example of the last one we just did. So we're still doing polynomials times polynomials, but in this case we're going to do binomials times binomials. So exactly two terms times two terms. And so we should initially end up with 4 terms to start. And sometimes there will be like terms in there, and we will be able to simplify it. Now when you do a binomial times a binomial and you use the distributive property, this is often called FOIL, which you might have heard of before. And FOIL is just an acronym to help you remember what to do in order to multiply and use the distributive property. So FOIL stands for first, outer, inner, last. So the way that works here is if I want to do r minus 6 times r plus 8, in the distributive property, we should be taking the r times the r to begin with, and that's your first times your first. And in this case, r times r would be r squared. Then I would take the r times the 8, and that's the outer number here and the outer number here. So these ones closest to the end parentheses, those are your outer two numbers. And r times a positive 8 is a positive 8r. Then if I do the two numbers on the inside and do negative 6 times r, those are called your inners. So negative 6 times r would be negative 6r. And then if I do the negative 6 times the positive 8, that's the last number times the last number, and that is a negative 48. So first, outer, inner, last means first times first, outer times outer, inner times inner, last times last. But that's otherwise known as the distributive property. It's just a fancy name. FOIL is just an acronym for helping you remember to apply the distributive property. Now you don't want to stop here because oftentimes the inner and the outer terms here result in like terms that can be combined. So in this case I have an 8r and a minus 6r. So those will combine into a positive 2r. So my final answer here will be r squared plus 2r minus 48. Okay, now let's try that again with this next example. So we're going to do first times first. 2x times 3x would be 6x squared. Outer times outer would be 2x times a positive 1, which just stays 2x. Inner times inner would be negative 4 times 3x, or negative 12x. And last times last gives me negative 4 times positive 1, which is negative 4. And then I have like terms here in the middle, so those will combine, and we'll have 6x squared. 2 minus 12 is a negative 10x, and then the minus 4 on the side. And it's really important that you very comfortably understand how FOIL works, because in this case we're multiplying and we're getting rid of the parentheses to get this expanded trinomial right here. But when we get to factoring in a later lecture, you're going to start with the trinomial and have to work backwards to come up with the two factors in parentheses that would give you that if you were to refoil it out. And factoring is oftentimes much harder to do than just basic multiplication. So it's good to have a good understanding of the distributive property in FOIL so that it'll be easier for you to see how to factor your trinomials. So the next thing we're going to talk about is just a couple of patterns that often develop that you'll see. And the first one deals with anything of the form x plus y quantity squared, or some two terms added together in parentheses quantity squared. So this is called a square of a binomial. So let's see what this would turn into. So if I want to find x plus y quantity squared, remember what that means. That means you're really taking x plus y, and when you square something, you're multiplying it by itself. So we're going to multiply x plus y by itself. So it's x plus y times x plus y. Now if we FOIL that, that's going to be first times first, or x times x, which is x squared. Outer times outer, x times y is a positive xy. Inner times inner is a y times x. Now remember that y times x is the same as x times y because of the commutative property of multiplication. The order that you multiply two things in doesn't matter. So instead of writing this as yx, I'm going to rewrite it as xy so that it has the same form of the other middle term that I already have, and it'll be easier for me to combine these when I go to simplify later on. And then finally, don't forget your last times last, y times y would be y squared. So these two middle terms are like terms because they both have an x to the first and a y to the first. And this is like a coefficient of 1 and a coefficient of 1. So if I'm adding those two together, I combine the coefficients. 1 plus 1 would make this 2, and then the variables stay the same. So the middle term becomes 2xy. And then that plus y squared on the end. So anything of the form x plus y quantity squared becomes x squared plus 2xy plus y squared. Now we're going to think of this as a pattern. So we're going to generalize this so that instead of only making this example be true for x plus y, what if the expression that was right here was anything, and what if the expression right here was something else completely different? That's what this pattern is down here. And so what we see is that anytime you have a quantity, I'll call it a square, added to a triangle, and these boxes and triangles could represent x's, they could be numbers, they could be y's, they could be anything at all, then there's a pattern to this where your square of a binomial, if you were to FOIL this out, it ends up just being whatever is in this first spot where we had x before, we square that, and whatever was in the spot where y was, we squared that. And the middle term was a result of taking whatever was what we called x and whatever was what we called y, multiplying those two together, and then doubling that in the middle. So this is our pattern. And this pattern is something you can memorize if you want. It's just an alternative to FOILing something out. It's just a quick way of getting out your reduced, simplified polynomial without having to go through the process of FOIL. So the pattern works like this again. You take whatever is in this first position and you square it. You take whatever's in this second position and you square that, and that goes on the end. And the middle term will be the square times the triangle doubled. So 2 times the square and the triangle. And then notice the signs here. The triangle squared on the end is always positive, no matter whether this is a plus or a minus in the middle. And then the middle term has whatever sign you have to begin with inside your parentheses. So let's see an example of how you would use this pattern. So in this case, x minus 4y quantity squared. This is like our box, and the 4y is like our triangle. So if I wanted to FOIL this, that's fine. If you don't like to memorize, you can always FOIL this out and you'll get the same answer. This formula up here is just meant to be a shortcut for you to get your solution to what this will multiply out to, so that you don't have to do all the work of FOILing. So if we apply this formula or this pattern, here's how it works. You take whatever is in this first position. In this case, my box here is just x. So I'm going to take that x and I'm going to square it. Then I'm going to take that 4y and I'm going to square that. And when you square 4y, you have to square the 4 and you have to square the y. So 4 squared becomes 16 and y squared becomes y squared. And that n term is always positive, no matter what the symbol is or the sign is inside the parentheses. Then, to get the middle term, you just take whatever's in this first position times whatever's in this second position. So x times 4y would be 4xy. And then remember, we have to double that because we actually get 2 of those in the middle. So I'm going to double this, and 2 times 4xy would become 8xy. And that is now my middle term. Since this was a minus in the parentheses, my middle term will be minus as well. So this is what we would get if we were to FOIL this out and then combine like terms. Okay, so let's try it one more time. So in this next example here, 2r plus 3s quantity squared. I'm going to think of the 2r as my square and the 3s as my triangle. So if I apply this pattern, I'm going to take the 2r and I want to square that first. So 2r quantity squared becomes 4r squared. Then I'm going to take whatever's in this triangle position, this 3s, and I'm going to square that. So 3 squared and s squared becomes 9s squared, and that's always positive. And then for my middle term, it's these two multiplied together. So 2r times 3s, and then I have to double that because I'm going to get 2 of them for my middle terms. Well, 2 times 3 would be 6, so when I double that, it becomes 12, and then I'm also going to have an r and an s in the middle. And because this was plus, my middle term is plus as well. So here's what we would get when we FOIL it out. Okay, so now we're going to learn one last pattern. And this one is kind of similar to the last one, but actually a little more simplified. So notice the difference here. This time we're not multiplying x plus y times itself. We're multiplying it by something very similar, but the two signs in the middle here are opposites. So x plus y times x minus y. So they almost look identical, but the signs have to be opposites. So let's see what happens when we FOIL this out. So if I do first times first, x times x is an x squared. Outer times outer, an x times a minus y will be a minus xy. Inner times inner will be a positive y times x, so that's going to be a positive. And you can either write yx or xy, and I'm going to write it as xy so that I'm consistent and I'm using the same order that I did in my earlier term. And then last times last, a positive y times a negative y is going to be negative y squared. Now here's the nice thing about this particular pattern. When these two things in parentheses are identical except that they have opposite signs, what happens is that this middle term and this middle term will always be the exact same thing, but they will have opposite signs as well. So when I go to combine them, I'm going to see that they cancel each other out because one is positive and one is negative. And so all that's left is the x squared term in the front and a minus y squared in the back. And so this is called a difference of squares pattern because what you're left with here is a square minus a square, a difference of two squares. And so anytime you have this pattern where you are multiplying two binomials that are exactly the same except they have opposite signs, the middle term that you're going to get will always cancel out, and all that you're going to be left with is this first term squared, so that's this box squared, and then the second term, or triangle in this case, squared with a minus sign in between. And the minus sign is there because a positive times a negative will stay negative. So this is a nice simple formula, and it is one that you will use and see quite often in factoring. So this is definitely a pattern that I would recommend memorizing. So how would this work on this example? Well, first you want to recognize that you have a difference of squares pattern. And I do in this case because these two things in parentheses are identical except for the signs. So according to this pattern, all I'm going to get for my answer is whatever is in this first spot squared, and 2 squared would just be 4, minus whatever is in this second spot squared, and r squared just stays r squared. So this thing FOILed out is going to be a 4 minus r squared. And remember, there's no middle term when you're using this difference of squares pattern because the inners and the outers will always cancel each other out because they're going to have opposite signs. So your answer will only have 2 terms in it. Okay, so one last example. Again, this is that difference of squares pattern because these two binomials are identical, but they have opposite signs. So if I apply my formula here, or my pattern, I'm going to take whatever is in this first spot and I'm going to square it. So 3 squared would be 9, x squared is x squared. And then I'm going to take whatever is in this second spot and square it, and that will become a 4y squared, and then we want the difference of those 2 squares. And I don't have to worry about any middle terms because I already know that they're going to cancel out because this is a difference of squares pattern. All right, that concludes our video lecture on polynomials, adding, subtracting, and multiplying. Good luck!